So we're going to have another look at a question. This comes from the 2020 HSC Advanced Maths paper. So this is question 25. So we're told a landscape gardener wants to build a garden in the shape of a rectangle attached to a quarter circle. That's important. We know area of rectangle, we know area of circle, so we know these areas. Let x and y be the dimensions of the rectangle in meters. The garden bed is required to have an area of 36 meters squared to have a perimeter which is as small as possible. So we know the area of the whole thing has to be 36 meters squared. Let p meters be the perimeter of the garden bed. Show that p is equal to this as a function of x. Okay, so we're going to draw a diagram. We're going to find some dimensions here. So this is y up here. Because this bit is a rectangle, this must be y down here. This bit over here is x. Because this is a rectangle, this bit over here is x. And because this is a quarter circle, it has the same radius. That means this is x. Now, because we know the radius is x and it's a quarter circle, we can calculate the curved section here. The circumference of a circle is 2 times pi times the radius. So the circumference of a full circle, one that looked like this, would be 2 pi x. So the circumference of a quarter of that is 2 pi x divided by 4, which is pi x on 2. So we have this. Now we know the area of the rectangular part of this shape is xy. And we know, so we'll call this area 1. And we know the area of the circular part, but of a circle is pi r squared. Area is pi r squared. The radius here is x. So the area of a full circle, this size, would be pi x squared. So this area is going to be pi x squared divided by 4. Now we're going to add all of the perimeter sections together. So p is x plus y plus x plus y plus pi x over 2. This is perimeter is 2x plus 2y plus pi x over 2. Now this is a good start because this sort of looks like the answer that we're after anyway. It has a 2x plus something. Ours has 2x plus something. The somethings are different though. So really what we need to do at this point is show that 2y plus pi x on 2 is equal to 72 on x. And we're going to do that by using the areas. So an important piece of information we were given at the start is that the area of the garden bed is definitely 36 meters squared. This means the sum of the two areas in the shape will be 36 meters squared. So we know 36 is going to be equal to x times y plus pi x squared on 4. We can now rearrange this for y. So we get xy is equal to 36 minus pi x squared on 4. Divide everything by x. And this gives us y is equal to 36 divided by x minus pi x divided by 4. And so we now have a new equation in terms of y. We're going to sub this in to this equation where the y is. So this will give us p is equal to 2x plus 2 times 36 on x minus pi x on 4 plus pi x on 2. So when we start to expand this, we find p is equal to 2x plus 72 on x minus 2 pi x on 4 plus pi x on 2. Well, these actually cancel. So therefore, the perimeter is equal to 2x plus 72 on x. This is the perimeter as a function of x with the condition that the area of the total thing is equal to 36 meters squared. And so this is the answer to this question. Now, in terms of the marking is going to be a little bit varied in this type of question. You are going to get 1 mark for setting up the shape and the individual areas and the perimeters and attempting to find some kind of perimeter. So if you have some attempt to find a perimeter, if you get vaguely close to getting this perimeter, but not quite the whole way, you'll get 1 mark. You'll get 1 mark for reasonable working here. The second mark is really going to be given for a way of substituting the y out or equivalent. So if you're using this method, in the method I've used, I've set up the perimeter, then I've substituted in a y. If you use a different method, it will look slightly different. In this method, the second mark will be for the y. So getting the y from the given area condition, that's going to be the second mark. And then the final mark will be for getting the perimeter being equal to 2x plus 72 on x. Now this question has a second part. The second part, this question is worth a lot of marks. 7 marks is a lot of marks for a 2 mark. It's a very, very high mark question. This second part is a little bit complicated. So find the smallest possible perimeter of the garden bed, showing why this is the minimum perimeter. Now, we have to be careful here because this has 2 parts. Find the smallest possible perimeter, show why it's the minimum perimeter. There's going to be several ways to go about the second part. The first part is pretty much just going to be derivatives. Whenever someone says find a minimum, find a maximum, something like that, it's probably derivative of the function equals 0. That's typically how you find minimums and maximums. So if we want to minimize the perimeter, we need to differentiate this function. So p is 2x plus 72 times x to the minus 1. Now I've changed the divided by x to x to the minus 1 because it's going to make it a little easier to differentiate. So dp dx, the derivative, is 2 minus 72x to the minus 2. So this is our derivative, and in order to find a min or max, the condition we need is to set this equal to 0. So we're going to set this equal to 0 and solve. We're going to add 72x to the minus 2, 72x to the minus 2 to both sides. This will give us 2 is equal to 72x to the minus 2. Divide both sides by 72. 72. Divide this by 72. So give me 1 on 36 is equal to 1 on x squared. Now you rearrange this, you'll get x squared is equal to 36. So this means x is plus or minus 6. This is the answer that the formula gives us. When we look at the shape we started with, the x and y's are positive. Right? This is a condition. This is a garden bed. These are measurable distances. So this means actually x will be equal to plus 6, because in the context of the question, plus 6 is the measurement we want. Minus 6 is just not a viable answer, essentially. So find the smallest possible perimeter. Well, the x value that gives us the minimum or maximum perimeter is going to be x equals 6. So we're going to plug this into the perimeter formula. So the perimeter is 2 times 6 plus 72 divided by 6. 2 times 6 is 12. 72 divided by 6 is also 12. 12 plus 12 is 24. 24 meters. Now, show why this is the minimum perimeter. There's several ways to go about this. One, you could check values of x slightly to either side of x equals plus 6. And this is a perfectly fine method. Some people complain about this method. They say, oh, you haven't used fancy derivatives or super fancy calculus in order to do this. You don't need to, right? Anything that demonstrates that this is a minimum is going to be acceptable. So if you check x equals 5.9 and x equals 6.1, and you find that they both give bigger perimeters, because this is continuous, it must be true that x is 6, therefore gives the minimum perimeter. So this is one way to go, perfectly good way to go. Another way to go is to find the second derivative of the perimeter and then just look at its value, right? Is it positive or is it negative? This will tell you whether it's a minimum or maximum. So we worked out, and I'm going to do the second derivative here because I like derivatives. You don't have to do this, but this is a good way to go. Using derivatives in the advanced maths course is always good because that's sort of what the course is about. But if you don't have to, you don't have to, right? Don't fall for the trick that lots of, especially students, I argue with students a lot about this, and they say, oh, no, I have to use the second derivative, otherwise I'm not showing that it's true. No, there's many ways to show that it's true. You could check points. The derivative also works. I like the derivative, so I'm going to use it here. So we worked out the first derivative was 2 minus 72 over x squared. This is this. X to the minus 2 is the same as over x squared. So now the third derivative, d squared p d x squared. The 2 is just going to go away. So this is actually 2 minus 72 times x to the minus 2. This will become, minus 2 comes down the front, 144 times x to the minus 3. And we know x is always greater than 0. And for the case of x is 6, or in fact for the case of every x value, this will be positive. Right? D squared p over dx squared is always going to be greater than 0, because there's no way to make this negative. 144 times a positive number to a positive or negative power, this is always greater than or equal to 0. Greater than if x is greater than 0, could be equal to 0 in the case where x is 0 if it didn't have a negative power, but x is always positive, so this is always positive. Therefore, x equals 6 is a min value, and therefore p equals 24 is a minimum perimeter. So using derivatives here, I personally like. I think derivatives is quite nice, but you don't have to, right? This mathematics course is about teaching you rules in order to solve problems and show that they have solutions. If that includes using derivatives, it includes using derivatives. If it doesn't include using derivatives because you don't need them, then you don't have to. Right? And it's a very, very common mistake. If you hear other students in your class say, oh no, you can only do it this way because this way is super complicated, that might be true sometimes, but often that's wrong. Right? You can use any method that works, that is contained within the curriculum, including old methods or including simple methods like checking. Right? This is part of the curriculum, so derivatives will work, checking points on either side will work, either way is fine. If we have a look at this marking, there's a lot of marks here. The marking is going to work pretty much as follows. You're going to have to identify that to minimize or maximize, you will have to find a derivative. So you'll have to get a derivative of the perimeter function. You'll then have to correctly identify which x value minimizes or maximizes that function. A third mark will likely be for a combination of finding the perimeter and finding the second derivative. So finding the perimeter, finding the second derivative, or starting to check values on either side. And then the fourth mark will be if you have a completely correct solution. So you have a first derivative to find the min or max, you find what that x is, you find what that perimeter is, you then use some correct method in order to show that that value definitely gives a min, and your working is all nice and readable, nice and logically cohesive, regardless of what method you use, that will get you the 4 marks. And these are the kinds of the questions where the markers will sort of vary their marking a little bit. So long as you have something completely cohesive that completely answers the question, it's likely that you're going to get 4 marks.